Hi, my name is Ashley and this is my Physics Lab 7. In this lab, I analyzed the motion of a star around a black hole and used Python to model this, and then used my Python model to predict the mass of the black hole. So to do this, first I imported all of the data given to me into our lab from in class. So you can see here I put in the mass of the star and my time step, as well as changing the CSV data to Lab 7 Home, which is my set of data here. And then I also added in our black hole position, which is this vector here. I also adjusted all the arrows. So in this case, FNet is going to be represented by black. FNet parallel is represented by blue, and FNet perpendicular is represented by red. So once again, perpendicular is red, parallel is blue, and FNet is black. And you can see when I run this model, these arrows are represented. And I also went into my code and used Newton's gravitational force law to predict the mass of my black hole. So Newton's gravitational force law says that negative g times mass 1 times mass 2 divided by the distance between the two squared will give you the force of gravity on 1 by 2. So you can alter this and move it around to find your mass 2, which in my case is the mass of my black hole. So this is shown here. So we have the mass of the black hole equals the magnitude of the force times the magnitude of the position of the black hole minus the magnitude of the star position squared. And that you can see there, that's our r squared value, divided by g, which is 6.7 e to the negative 11 times the mass of the star. And then when I ran this, which we'll run it one more time, you can see that it will print it after it completes. It's printed there. And then here we can see that that is our mass. So next we're going to analyze the differences between FNet perpendicular, FNet parallel, and FNet with delta P over delta T over delta T parallel, and delta P over delta T perpendicular. So these are all going to correspond perfectly with their values. So each numerical value is going to be exactly the same. The main difference in these is that they're derived differently. The FNet forces are going to be the accumulation of all the forces acting on the star, while the change in momentum over the change in time is exactly that. And so they're derived very differently, but the numerical values will end up being the same. In relationship to each other, FNet parallel is going to always run in the direction parallel to the force, and perpendicular will run at a 90-degree angle to FNet. FNet parallel can run in the same direction, or I guess what you'd call anti-parallel, which is where it runs in the opposite direction, or the opposite, the arrow points in the opposite direction, but it's still parallel to FNet. So what if the black hole was replaced by a new black hole in the same location, and the motion of the observed star remains unchanged and is unaffected by the gravitational force of the new black hole? Or it is affected only by the gravitational force of the new black hole. The answer to this question is that no, you would not be able to tell the difference. If you were to replace the black hole and the star would go unchanged, then we would assume that this means that the mass and the gravitational pull are going to be the equivalent to that of the black hole that we already have analyzed. So thank you very much.